In this video, we're looking at a fairly simple trig equation, and we're going to solve it. So this problem says, find the values of x in the interval 0 is less than or equal to x is less than 360 degrees, such that 5 times the cosine of x plus 7 is equal to 3, to the nearest tenth of a degree. Good. So that we have room, I'm going to bring this equation down. So this is 5 times the cosine of x plus 7 is equal to 3. As with any equation, first we isolate the function. So we are going to, I will subtract 7 from both sides. We get 5 times the cosine of x is equal to 3 minus 7 is negative 4. Now we'll divide both sides by 5. So we have the cosine of x is equal to negative 4 over 5. I don't recall a negative 4 over 5 as an exact value of any of the special angles, and so in this case we're going to use the calculator. To use the calculator, I'm going to make sure that it's on degrees in this case. Why is that? Well, it's because it wants us to give the answers to the nearest tenth of a degree, and so I'm going to put the calculator on degree by going to mode and checking to make sure that it's on degrees. Right there it is on degrees, so that's good. We can back out of that. And what we're going to do is we're going to take the inverse cosine of both sides. So the inverse cosine of the cosine of x is equal to the inverse cosine of negative 4 over 5. The inverse cosine of the cosine of x is just x, so x is equal to this, and what does the calculator give us for that? Here we have the inverse cosine of negative 4 over 5, so we'll type that in, second cosine, and this is negative 4 divided by 5. See how I typed it into there exactly the way that this looks? There's my negative 4 over 5. And we press enter, and it says that it's 143.1301024. This wants us to give the answers to the nearest tenth of a degree, and so 143.13 rounded to the nearest tenth. We look at that 3 is less than 5, and so we will not bump up the 1, we'll leave it as a 1, and so we end up with x is 143.1 degrees to the nearest tenth. Of course, that's not the only possible value. As soon as we have one value, now we can find another value by reflecting. So I'm going to draw in a unit circle. We're going to estimate where 143.1 is. This does not have to be very accurate, but you do want to make sure you put it in the correct quadrant. Since this is 90 and this is 180, 143.1 is in the second quadrant, and I estimate that it is perhaps about there. So the size of this angle, that is 143.1, and we are going to reflect this across the x-axis because this problem involves a cosine. When you have a cosine, you should reflect across the x-axis, and so here we have the 143.1, and reflecting this angle across the x-axis puts us right here. Notice that these 2 points have the same x-coordinate. That's what we want. So what is the size of this larger angle? Well, if this is 143.1, how many more degrees do we have to add in order to get all the way to 180? To do that, we'll take 180 minus the 143.1. 180 minus 143.1 gives us 36.9. So that means that this angle right here is 36.9. But if this is 36.9, that means that this is also 36.9. And so to go the entire distance from the x-axis all the way to there means we've gone 180 plus 36.9. So I'll calculate that down here on the side, 180 plus 36.9. When we add those together, we end up with 216.9 0.9. And so the other solution is 216.9 degrees when we are rounding to the nearest tenth. These are the only two solutions because in this problem we just wanted to find the values of x that are in this interval. So the values of x that are between 0 and 360. Here they are. These are the final answers.